With the trend in Industry 4.0, the Internet of Things, IoT, is growing vigorously. The low-power wide area network, LPWAN, has become the major supporting kilometer-level wireless deployment in large-scale IoT networks. Major LPWAN networking protocols include long-range wide area network, the LoRaWAN, narrowband IoT, the NB-IoT, and Sigfox. LoRaWAN uses ISM-free licensed band, has maximum data rate of 20 kbps, and reaches at most 10 km network coverage. Sigfox uses ISM-free licensed band, has maximum data rate of 100 bps, and reaches at most 40 km network coverage. NB-IoT uses cellular networks, licensed band, has maximum data rate of 200 kbps, and reaches at most 10 km network coverage. With these major LPWAN technologies being designed with different specifications and different interfaces for IoT wireless modules, the challenges of incompatible IoT infrastructure arises. There are mainly three aspects of incompatibility issue. The first one, incompatibility in the API between the user-defined applications and the network management platforms. Different platforms have different data exporting API design, different user-deployed application authentication processes, and etc. The second one, incompatibility in adopted Internet protocols between the radio gateways, base stations, and the network management platform. Different gateways platforms support different Internet protocols that lacks interoperability. The third one, incompatibility between the devices. For example, devices designed for specific application obtains too much network resources that cannot work in the same network with other devices. These incompatibility issues arise due to the non-standardized design structure and broad challenges of incompatibility of various aspects. The IEEE P1451.5.X standards group are developed for major LPWANs to mitigate the incompatibility issues in LoRa, NB-IoT, and Sigfox, namely 1451.5.10 for NB-IoT, 1451.5.5 for LoRa, and 1451.5.6 for Sigfox. The IEEE P1451.5.X define the major components for the LPWAN structure and standard: the wireless transducer interface module, the network-capable application processor. It also defines the standardized information form which the LPWAN components needs to follow, the transducer electronic data sheet, and the communication API. Each W team needs to use the information in the test to configure their physical transmission with the NCAP through gateways or base stations. CAPI are designed to read the tags, configure the transmissions, and transmit in both W team and NCAP. Standardized tests and CAPI leads to interoperability between different network management platforms, different gateways, base stations, and different end-node devices. They also enable the plug-and-play feature that requires no human adjustments. These are the materials and hardware used in the demonstration. A sample physical test in CSV file format is ported to both the PyCom test board and the deployed sample network server. When the CSV file is read and used in configurations in physical layer of WTIM automatically joins the respective network management platforms. We modify the application payload to send data of temperature 30 degrees. Then we will see the received data at 30 degrees here. Thank you for listening.